Okay, so the next thing we're going to take a look at are some word problems where Pythagorean theorem will help us solve. So let's take a look at what you got from the front. You should have these 4 example pages. It's 2 and 2. And what we're going to do is this little section right here is going to get taped down. Okay, so we're taping right here. Okay, so tape that down to your notebook and have the examples on the inside. So make yours look like mine. It doesn't matter if these are far apart or close together, but we do want the words example on the inside. Okay. So have your paper look like this. What's going to happen is, you're going to end up folding each of these open. And on the back side, we're going to draw our picture, and on the lined paper, we're going to work out the problem. So what we have right now is they should be split right here. You've taped them right here. All right, cool. All right, so let's take a look at our first page. Okay, so what we have right here is our first problem. And it should be the one that says Kylie let out 45 feet. So this is the Kylie problem right here. This is the back side of it. All right, so what we're going to do is we're going to draw the picture on the back of the paper, and we're going to do the work here. So the picture will go here, work will go here. Okay? All right. Okay, so we've got Kylie let out 45 feet of kite string. Her kite is directly above a tree that is 20 feet away. How high is the kite? Okay, so we've got Kylie right here. Kylie's gorgeous with her blue hair. And she let out 45 feet of kite string. And here's her kite. So she let out 45 feet of kite string. Her kite is directly above a tree. So she's directly above a tree that is 20 feet away. When they say 20 feet away, they're talking from Kylie. So since we've been talking about Kylie and the kite is let out 45 feet, it's above a tree that's 20 feet away from Kylie. Okay. Now, in all of these word problems, you can assume that anytime we have any of these situations, we're dealing with a right angle. So from the tree to the ground, you can assume there's a right angle. Okay, we can make that assumption because we're working with Pythagorean theorem. So what I have here is I have my C is 45 feet. We'll call 20 feet my A, and I don't know what B is. We're looking for the height of the tree or the height of the kite. Same thing, because the kite is directly above the tree. So if we put this into our formula, I get 20 squared plus b squared equals 45 squared. And now we just go through and start solving our equation. So 400 equals b squared, which equals 45 squared. Definitely want to use a calculator for this. And 45 times 45 is 2025. Now we just need to solve for b. I get b squared equals 2025 minus 400 is 1,625. Now we're going to find the square root of each. Square root of 1,625 is about, so let's make these the approximate, 40.3 feet. So that kite is about 40 feet above the ground. Tree is about 40 feet high. All right. Again, on these word problems, sometimes they'll tell you how to round, sometimes they won't. Okay, let's look at the next one. Let me scroll down to our next problem. All right. Okay, so our next situation, if we look down below the Kylie problem, says the bottom of a ladder. Okay. So that's the one you want to be looking at, the bottom of a ladder. So we have a ladder, and the bottom of this ladder is placed 6 feet from the side of a building. So I have a building right here. Oh, that's horrible. Okay, so I have a building right here. Okay. And the bottom of a ladder is placed 6 feet away. So here's the bottom of my ladder. Now, when you use a ladder, you put the ladder up against the wall and you tilt it sideways. So here's my ladder. And this is the ground. All right. So the bottom of a ladder is placed 6 feet from the side of a building. The top of the ladder must be 16 feet off the ground. So this spot right here, the top of this ladder must be at least 16 feet off the ground. For whatever reason, that's some sort of height requirement for one thing or another. What is the shortest ladder you can use? So we're pretending that you can go find different size ladders, and you don't want one that's too big, because if it's too big, then it's not quite as stable. So you want to find the shortest ladder possible, just because physics, if you have a longer ladder, that means that it's a little bit weaker, it may not be as strong. So we want to find the shortest ladder possible. So that means my C is what we're looking for. Okay, so our A would be 6, B would be 16. Again, we're up against a building. Building to the ground, we're assuming, is a right angle. So my ladder is C. So 6 squared plus 16 squared is going to equal C squared. 36 plus 16 squared, I'm going to double check with the calculator. It's 256. It's going to equal C squared. So we add these together, we get 292 equals C squared. Okay, we're going to square root each side. And the square root of 292 is about 17.08. Now here's something I want you to think about for a second. Could you see yourself going to Home Depot and buying a 17 8/100 foot long ladder? It doesn't make any sense. You're not going to find a ladder with a decimal point measurement. I don't even know if you can get a 17-foot ladder or an 18-foot ladder. But we're pretending that you can do that. We're pretending that that's reasonable. The thing with this question, and this question is going to be on your test. Okay, so this type of question is going to be on your test. We want to know the shortest ladder that we can get. Now, I need it to be at least 17.808 feet. At least. The minute I go down from this number, it's too small. So again, the minute I go down from 17.08, it's not 16 feet up the building anymore. So in this type of question, what's important to note is round up to the nearest whole number. Round up to the nearest whole number. So our answer is going to be 18-foot tall ladder. Okay, very important. If you, on the test, if you say 17.08, you're going to be wrong. You'll get a point for good work, but it's not going to be, you're not going to get the full points. So please be careful. Okay, let's take a look at the next one. Our next problem here is going to be the bases on a baseball diamond. So find that problem. So we're going to go ahead and draw our baseball diamond. Bases on a baseball diamond are 90 feet apart. So if you're unsure what a baseball diamond looks like, we look like this. Okay, this is home. This first, second, and this is third. Okay. Now what we want to know is if the bases are 90 feet apart, how far is it from first base to third base? So I want to know how far this is. So if I take a look at this piece right here, this could be my triangle. My right angle is right here. I have a right angle where the A is 90, the B is 90, and the C we do not know. So over to the side, let's do our work. 90 squared plus 90 squared equals C squared. 8,100 plus 8,100 equals C squared. This is going to be 16,200 equals C squared. We're going to square root each side. So 16,200. If we square root each side, I end up with about 127 and 28/100 feet. So it's just about 127 feet. Okay, let's take a look at our last problem. Last problem says, Jamie's house is 50 yards away from Mike's house. They're across the street from each other. Teddy lives next door to Mike. Mike lives 56 yards away from Jamie. How far do Mike and Teddy live from each other? All right, so there's a lot going on here. The hardest part about these problems is just figuring out what they're talking about. So let's start with Jamie. Jamie lives across the street from Mike, and they are 50 yards away from each other. Now, Teddy lives next door to Mike. Okay, so there's Mike's house. Here's Jamie's house. Oops. And here's Teddy's house. So Mike and Teddy are next door to each other. But then it's telling us Mike and Teddy are next door. However, Mike lives 50 yards, Oops, hold on a second. We have to fix this problem. Mike lives 50 yards away from Jamie. Nope, that should say Teddy lives 56 yards away from Jamie. So change that Mike lives 56 yards to Teddy lives 56 yards. Sorry about that. That was a typo. So Teddy lives 56 yards away from Jamie. Okay. Jamie's house is 50 yards away from Mike's house across the street. Teddy lives next door to Mike. Mike lives 56 yards away from Jamie. So change that to say Teddy lives 56 yards away from Jamie. All right. So what we're trying to find out is how far do Mike and Teddy live from each other? My next door neighbor guys. So if you look at this, it creates a right triangle. Okay. And so my 50 yards can be A, my question mark can be B, and my distance from Jamie to Teddy can be C. So we have 50 squared plus B squared equals 56 squared. 2,500 plus B squared equals, let's see what 56 squared is. $3,136. Start solving. And I get B squared equals 636. Let's go ahead and get the square root of each side. And we've got that Teddy and Mike live approximately 25.2 yards away. Okay, that's it.